You're welcome to Come by Matrices. If you are joining us for the first time, please kindly subscribe for more contents from this channel. Also comment and like the page. Thank you. Alright, today we'll also continue with the topic we've started, Introduction to Matrices. And today we'll be looking at the algebraic aspect of matrix. We are building a systematic approach of matrix before we solve problems in determinants and also system of linear equations. So as a result, today we'll be looking at the addition aspect of matrices. Now, what is addition of matrices? Remember from the previous class, if you are just joining us, please kindly refer to my previous tutorials on this, where you learn on order of a matrix, whether you can be able to add a 2 by 2 or 2 by 3, a 3 by 2, a 2 by 1 matrix. Is it possible to add? If you don't understand, or you have not studied such, you might not be able to understand how we add matrices here. So here we have addition of matrices if A is equals to Aij and B is equals to Bij, are matrices of order m by n. Then the sum of the matrices is m by n. This implies that if you are adding a square matrix, the answer must be a square matrix. If you are adding a 2 by 2 matrix and a 2 by 3 matrix, it must end up being either a 2 by 3 or a 3 by 2 matrix. So this is what it is here. So it means that by definition, A plus B is equivalent to Aij plus Bij for all I and J. This sign signifies for all I and J. Now let me take numerical examples so that we can be able to understand the definition of what addition of matrices. But before we take that example, there are certain things we learn from elementary mathematics, some properties of addition, subtraction, and multiplication. Do this work in addition or subtraction? These properties like commutativity properties, distributivity properties, and associativity properties. Now, in this aspect here for addition, we have properties of addition of matrices. Here, property 1, A plus B is equivalent to B plus A, provided that the order is the same. Also, A plus 0 is equals to 0 plus A is equals to A. These are properties of addition of matrix. And the last property here is if you have A plus B in bracket plus C is equivalent to A plus open bracket B plus C. These are the properties of addition of matrices, and these properties are typically commutativity properties. That is, whatever is in the left hand side must also be a reflection of what is in the right hand side. I want you to know that most of these properties are also linked to subtraction, but there's a little difference. When we discuss subtraction, I will explain the difference and the properties of subtraction. But before then, let's take example of addition of matrices. Example. Given matrix A equals to 3, 0, 1, 1, 1, 1, and then 2, 0, 1. Matrix B is the same thing as 1, 2, 1, 5, 1, 0. Matrix C is equals to 3, 1, 4, 5, 2, 6. Matrix D is equals to, we have 4, 1, 1, 3, 2, 1, 1, 2. Find A plus B. That is Roman figure 1. Roman figure 2, we have A plus C, and then we have B plus D. So we want to solve these problems on addition, and want to also check whether this is possible to add or it's not possible to add. Before you begin the addition, the first thing that you need to do is to check the order of the matrix. Now, we'll check for A. The order of A is, this one, A is 1, 2, 3, 1, 2, 3, 1, 2, 3. This is a 3 by 3 matrix. So this is a 3 by 3 matrix. A is a 3 by 3 matrix. B is 1, 2, 3, 1, 2. So this is a 3 by 2 matrix. C is also a 3 by 3 matrix, while D is a 2 by 4 matrix. It's a 2 by, we have 2 rows, 1, 2, 3, 4 columns. So this is 2 rows, 1, 2 columns. Sorry, for C. For C, I'm sorry. For C is actually supposed to be a 2 by 3 matrix. I'm sorry about that. It's a 2 by 3 matrix. While D is a what? Is a 2 by 4 matrix. Are we together? All right. So now this is a 2 by 3 matrix, and this is also a 2 by 4 matrix. Now we look at this. The order of this matrix cannot be added with this because they are of different orders. But let's look at this. B is also a 3 by 2 matrix. C is also a 2 by 3 matrix. But we cannot be able to also add this one. Why? The order of these are not the same. If you also check Roman figure 2, A plus C. A plus C. A is a 3 by 3 matrix. C is a 2 by 3 matrix. So as a result of that, a 2 by 3 matrix, as a result of that, they are not commutative. They cannot be added. Finally, B plus D. B plus D. B is a 3 by 2 matrix. D is a 2 by 4 matrix. So it's like adding sugar and salt, which is not possible. So since you can't add sugar and salt, it means that these matrices cannot be added. I give this example because of experience, where you will test students in a class for this kind of question. At the end of it, they will end up adding it just the way it is. But it doesn't work like that. It works based on the order of the matrix. I believe this one, with this one, you understand what is an order of a matrix. Please.